Hello everyone. Today I just want to show you a quick setup on how to rotate an object towards a specific direction. So this setup I created for a rock generation tool, which I was making for my demo reel. And I wanted to get the piece that had the largest area be rotated towards the ground. So the general concept of rotation was taken from an old CG Society forum post detailing how to rotate from one vector to another. To start out, I'm just going to create a box and fracture it. I like to set my box to the ground. I use the points of volume, that way I just need to skip over making a VDB and scattering points inside it. Now that I have my fractured geo, I just want to separate the inside pieces from the outside. And we've already been given this from an exterior and interior group. However, if we just place the blast node down and blast out that specific group, we're going to find that it doesn't actually blast out the entire piece, just the polygons. To fix this, I just need to expand the group. To do so, I'm going to use a group expand node. I'm going to set the group name to outside and the base group to outside as well, and then tick on flood fill to connected geometry. Now this setup, I want to run over all the different pieces in this geometry. To do so, I can just use a for loop, but for now I'm just going to use a blast, and blast the first piece and delete not selected. The first step that I want to do is figuring out which piece or which polygon has the most area. To do so, I can just use a measure sub. If we look at our geometry spreadsheet now, and we go over to the primitives, we can see that each primitive has now been given an area, but we want to find the maximum. The way we can do this is using an attribute promote. I'm going to promote the original class from primitive to detail, give it the area name here, and instead of average, I'm going to say maximum. And now this way, I can actually group which piece is the largest. By putting down an attribute wrangle here, connecting in the second input into my attribute promote, and I'm going to say set group. Inside here, I'm going to turn it over to run over the primitives, and then I want to get the current area from my detail. To do so, I'm going to say float A is equal to detail 1 for the second input, and then area for the attribute name. Now in my vex, I need to figure out which primitive has got the area that matches the attribute promote, which has been set to the maximum amount. To do so, I can say if f at area is equal to A, then group this. And to group this, we say at group, and then we give an underscore, and then we have the name. I'm going to call this bottom equals to 1. And now if we middle click here, we're going to see that one of our primitives has been given the attribute of bottom. Now, for the rotation amount, I need to figure out where I want to rotate to. I know that I want to rotate it downwards, but let's say this is the largest piece. Better yet, let's visualize this by going at CD equals set 1, 0, 0. Set it to red. Now if we rotate around, we can see that this piece here is the largest piece. And I want to make sure that this is actually facing downwards. So inside our primitives, we have this display primitive normals. Now this attribute is not given on the points themselves, but is actually given upon request. So let's request this. I can say at wrangle, and in here I can either set it to group for the group bottom, but I actually want to be able to use it for everything, so I'm going to turn this off, and I'm going to set this to primitives. Inside here, I'm going to say if at group is equal to bottom, then run this code. This may seem counterintuitive, but this is so that it doesn't, because I want to run over everything, and I don't want it to miss anything else. Inside here, I want to make all the points face the same way as this primitive normal here. For that, I'm going to make a quick for loop. This for loop now runs over every single point. If I wanted to set the normal or set an attribute on here, I need to use the set attribute point function. The function gives 5 separate inputs. The first one being the geometry that we're going to be run over. The second being the attribute name we're going to be setting it to. The third is going to be the current point number. The fourth is going to be the type and the value. And then finally we just need to say set. So let's make our type. Now we have a vector n, and we are putting the n to our points here. But let's get our primitive normal instead. To do so, we need to use the function prim normal. Prim normal only takes 4 inputs, so we're going to say 0 for the first input we want to run over, attribute prim num for the current prim number, and then I'm going to say 0.5 and 0.5 to get the very center. And now we can see that we are setting our normals to the exact same one as our primitive. This isn't exactly all that we want to do though. We want to rotate this primitive around. And the way we can do that is we're going to set a normal that we want to set it to. So I'm going to say this vector down is equal to channel float or channel vector downwards direction. And just run the spare parameters. I'm just going to set it to -1. So now I want this to face down to -1. Now to rotate this down, I want to use something called a quaternion, which is a vector 4. To create a vector 4 out of our 2 vectors, we need to figure out the rotation and the vector that we're going to rotate around. To do so, I'm going to say vector, it's going to be the rotation, which is going to be a cross between the normal, or our n, and our downwards direction. Then I need to figure out the angle. To do so, I'm going to say float angle is equal to the dot product between my n, or my normal, primitive normal, and my downwards direction. I'm going to rename this to normal, so that it's a bit better to visualize. Finally, I need to use the a cosine function, which is the inverse of the cosine. Now this is our correct angle and a rotation. Let's create a quaternion. To do so, I'm going to say vector 4, q, and I'm going to say quaternion, and our first input is our angle, and our second is our rotation. Finally, I'm going to set this quaternion to an attribute. I'm going to call this one trans for translation, and then I'm going to say q here. And now if we middle click, we shall now have a translation in a 4-float vector. If we open up our geometry spreadsheet, we can see that we now have a translation amount. So let's rotate this down. To do so, I'm going to use a point VOP. This is just so that it's easier to visualize. To start out, we can multiply our position by a matrix, which is basically how translations, rotations, scaling, and everything else works. What we can do is we can get our quaternion and turn our quaternion into a matrix. If we rotate our position by a newly created matrix, we will get our rotation. If we zoom out, we can see that it has indeed rotated, but it's rotated around the center and not where we want it to rotate around. So let's go back. To fix this, we will need to translate our geometry to the 0 coordinate and then rotate around that. However, we want to rotate around our primitive, so we first need to get the middle of where our primitive is. The easiest way to do that is through another for loop. So inside here, I want to get all the points that belong to our primitive here. To do so, I can say int points array is equal to prim points. This is going to give us a list or an array of primitives, of points from our primitive. Then I'm going to make a default position. And finally, I want to loop through every single point, get that position and add it to our current position. Finally, to get a proper position, we want to divide our added position and get an average of this. To do so, we just need to divide it by the length of our array. And now we have our position that we want to rotate around. So let's set this as another point. I'm going to call it position. And now if we middle click, we now have a new free float vector of position. So before we rotate around this, we want to position our geometry to the 0 coordinates based on our position. To do so, I'm going to bind in my position value, and then I'm going to use a transform matrix. The transform matrix is going to look very similar to the transform node. In here, I'm just going to bind import to the translation, and we can see it moved it further away. The way to fix this is just to negate it. And now our primitive is now set to the very center of our world. And now we can rotate it around. You may notice that our normals are a little mucked up. This is due to our quaternion matrix multiplying, rotating our point position around, but not taking into account our normals. So inside an attribute wrangle, let's get a list of all the points that are attached to our current vertex. So I'm going to run over the vertices. I'm going to say int points. Int point really is going to be saying vertex points. I'm going to say 0, then I'm going to say at VTX. This is going to give us the current point that our vertex is running on. Inside here, I now want to get our translation. Finally, let's make a matrix out of this. And now we want to multiply our normals. So that was the method of how we can do this in Vex. And this is how we do it in VOPs. But you may notice that it's not really setting it perfectly. So what we want to do is we want to keep on looping over this until it gets to a threshold. So we can do this is we can do a for loop. Say for loop number. We get the first input in here and the second input here. Inside our block end here, I'm going to set it to feedback each iteration and go up to our begin and say fetch feedback. And now we can see the more iterations we go over, the closer it gets to our goal. However, this is rather inefficient because we can set it to 1000 and it would barely move after the first 200 or so. So we want to get a threshold value. So the way we can do this is we can say at an angle here, and I want to check how close our current normal or primitive normal is to our downwards direction. The way we can do this is we first check if we are currently on the group. I'm also going to set this to primitives. Then I want to get our vector normal. I now want to just get a dot product between our normal and our downwards direction. And here I'm just going to enable the spare parameters, and I'm just going to copy and paste the parameters in here. Finally, I want to set this to the points. I've decided to call my attribute distance from position. Inside here, I can now set a stop condition. So the way we can do this is I can say point 0, 0. So the first input is the input that we're going to be running over. The second one is going to be the current point we're running over. Because I set them the exact value to all the points, it doesn't matter. I need to say the name that we're going to get it from, which is dist from position. And then I just want to get the x, y, z, w, whatever value that I want. Because it is a float, it's only going to have an x value, so I'm going to say 0. Because it is checking it immediately, it's just going to say yes, it's complete, and it's just going to give us a faulty feedback. A way to fix this is if we say add spare input, I want to get the point from my feedback, not from our threshold here. So I'm going to put for each begin into my spare input, and to access my spare input, I just need to say -1. However, this is still not working because it's stopping immediately. As you can see, it's giving us 2 feedbacks, and we want to actually set it to an actual threshold. So I'm going to say only stop if the threshold is above a certain number. The higher we go with this number, the closer it's going to get. Now, if we want to, we can now set this to go over a for loop. So I'm going to disable this one here, and we can see it's going to immediately access all the primitives, and it's just going to orient it by the largest piece, which is this one. But let's do a for loop. I can use a name attribute because I have created a Voronoi fracture. I'm just going to turn off my display primitives and normals and so on. And now we can see that they're all now currently oriented towards the base. If we wanted to try and speed this up a little bit, we can use a few compile blocks. So I have been getting a lot of errors with the compile block currently. If anyone knows the issue behind all this, we greatly appreciate it. But just a general overview, all I did was place down a compile block and a compile block begin. Unfortunately, it keeps giving an error. Sometimes it works, sometimes it doesn't. I hope that was helpful for some people. And that's just a simple way of being able to orient them all to the surface of our grid. I just quickly created a quick setup for a scatter node where I just scattered some points around. Please let me know if there was any other tips and tricks that I missed, and I hope to see you in the next one.